give a few words about you. So Lev Vaidman's a professor at Tel Aviv University. He's made important contributions in the foundations of quantum theory. We can think of his work on quantum teleportation. He's developed the approach to continuous variables, as well as the Elitzur Vaidman bomb tester and also the weak values. We are very happy to have you, Lev, on this conference. You are a very important defender of the Everett approach to quantum theory. And so yeah, just as a short recall, you will be speaking up until, I believe it's going to be 5 p.m. BST. So, well, let's go for 5:02. You have 50 minutes ahead of you. And we leave it up to you to divide. If you want to have more time for Q&As, then you can of course, finish before this 50 minutes to take questions. On that, I leave the floor to you, and thank you for accepting our invitation.
Thank you, Charles. You helped me to do what I'm trying to do for the last more than 30 years. I strongly believe that many words is by far the best interpretation of quantum mechanics, and I hope it will be a consensus soon. I was trying to do it before, but it wasn't easy beginning. It took me like nine years to publish my first paper. It was rejected in many journals, as you can see. And this is what is written there in the introduction. I consider many word interpretation the best available quantum theory. So this is what I would like to continue, and partly in the next 50 minutes. And I think the way to do this is to resolve controversies. And there are many. It looks like I disagree with all speakers of today. Clearly, I disagree with Wojciech and about the role of the coherence. And from reading abstracts of others, I think I disagree with them too. Okay, let's take some context. Science supposed to give us natural explanation of how the world works. And I want to explain my experience. This is, I think, what science is supposed to do. But not just kind of that I have an experience. I want to find a scientific reason for my experience. I believe that there is some ontology of natural world which explain my experience. Now, my experience is really my memories and my records. And I can kind of formalize them in scientific theories, saying that all my memories is kind of preparation of experiments and which they have some outcomes. And science is supposed to explain all these cases. If I remember that I prepared some experiment, it should explain why I got this or other outcome. Now, there are two kinds of experiments. Some experiments supposed to give me the same answer every time I make the preparation. Deterministic experiment. Maybe I think the best science which I would think would happen if all of them will be like this. But our practice tells us that this is not the case. Sometimes we make exactly the same preparation and we do get different outcomes. And so we have to explain this probabilistic experiment too. In this case, there is particular frequency which we can observe in the long run, and this has to be explained. I believe that many word interpretation is the only deterministic theory without action at a distance which makes this connection. And I think deterministic theory is much better than any other theory because it's give us more. And action at a distance, it's so bizarre, so strange. And if I can do without it, then the theory will be better. So let's kind of small interlude. I still that until today, there are some people that say that the collapse is not really action at a distance. I believe that unless you are really ready to get some weird ideas, single word quantum theory requires action at a distance. So I want to just consider a simple experiment. Not so simple. I think today we still cannot do this, but it's not unthinkable. So we prepare an EPR pair, like polarization or spin, one particle on Moon and one particle on Earth. And now I define a game. This game can be decided everywhere, maybe on Moon, but maybe on Earth. If it's made on Earth, that later we will check. There is a measurement in particular time on Moon. If the measurement gives us spin up, then you get $1. And for this game, you have to pay 10 cents. I think roughly there is a consensus today that if we have an EPR pair and the other particle is really nearest in a box and everyone sees that no one touches it, and so it's still an EPR, pure EPR pair, probability of up is 50%, else of down 50%. But the fact that probability of up 50%, that it's this game expectation value is 50 cents, and clearly you should pay 10 cents to play this. Now, in my position, this other particle, I measure it. Immediately after it, no one should play with me, because I will not offer a game if I know that the spin is up on Moon. I will play a game only if the spin is down on Moon. Clearly, this readiness to play game, it's a game about something on Moon. It's measurement on Moon. It's a property of this particle. You can put some ontology or you can put whatever it is. And the Bell inequalities tell us that there cannot be a hidden variable or anything like this, which will tell us from the what will be the outcome. So this 50%, the uncertainty of EPR pair for this measurement is accepted. And I can change it immediately. There is a 1 second for light to go there, and I can I can do it immediately by measuring my spin in another case. Measurement on Earth makes immediate change on the Moon. This all happened only if we believe in one word. If we believe on many words, that what happened when I perform my measurement, there are two words. One I find up, one I find down. On the Moon, one up, one down. There is a mixture of spins on the Moon, up and down. This mixture is equivalent to the initial state on the Moon. Nothing changed on the Moon. The original EPR state, or after my measurement, then didn't change anything on the Moon if you consider all words together. So single word quantum physics can explain things with definite outcomes. If I have a Mach-Zehnder interferometer, which I tuned for destructive interference here and constructive interference here, everything is well understood. Moreover, in principle, I also understood how the detector works and how I work when I hear the click and I turn toward the result. What I don't know to explain with single word quantum mechanics is the first part. If I'll put detectors here, if I have just this experiment and I send my single photon, the physics equation tell me that there will be some changes here and here. And also the changes in me, I will have to turn both to the left and both to the right. This is what tells me physics. We observe only one click here or one click here. Physics tell me there are two words. In one of them I see one, in another one I see another one. And many words is consistent with this. There is no problem. If we look on just one branch, here I see A, and here I see B. And I can be sure that there is no problem with existence of other world. So this is my many world picture. We start with some initial quantum state and it evolved. And this described worlds, different results of measurements. The fundamental ontology is this big wave function, big entangled in general big wave function. Now I have to connect this ontology to my experience, and it has two parts. The first part, which I discussed at length in 1 week ago, and you can go again into to hear my talk in Harvard workshop. In this, where I make connection between this particular configuration of wave and my single experience. And I briefly will repeat it here. The experience of an observer in a one world of many worlds, exactly the same experience as an observer in a collapsing wave function theory. And if I don't want to be a parasite on textbook quantum mechanics, I can define my world. In my world, by definition, all macroscopic objects, whatever it means, are localized wave packet in 3 dimensions. And the whole universe is a superposition of such wave functions. Now, there is one more part. It's about probability, which I didn't touch there. And this will be kind of the main issue in today's talk. And this, I believe, can be the meaning of probability can be introduced only if I'll talk about self-location of an observer in particular world. Okay, so let's start with this first part, which not about probability. How we can see the world around us. The textbook quantum mechanics has this picture. My textbook quantum mechanics, everything is just one wave function. This wave function, since there is no anything else, my experience is supervened on this wave function. It is collapsing wave function. But this collapse really put this wave function in 3-dimensional wave functions for all macroscopic objects, and some entanglement for constituents of this 3-dimensional of macroscopic objects. This picture, apart from the fact that collapse is unphysical, and I cannot believe that such a thing happened, it's random and it's action at a distance. A part of this, it explains very well everything what we see around. Our experience is only of macroscopic objects. Macroscopic objects live in 3 dimensions. This is the description of center of mass or any other collective properties. And I don't say there is any contradiction with Wojciech's talk, but I don't need it. At least for collapsing world, the coherence played no role whatsoever. What is many worlds picture? We have many pictures like this world pictures. Every world wave function is the same like collapsed wave function. This is like one wave function of many worlds. It's the same like what I had here. Here I had this world wave function. Here I have a many world wave, one of them. It's the same wave function. I will write it in the same way. It has the same property. All macroscopic objects are well localized. And there are many of them. I need to explain why these others don't disturb me. And again, I see the coherence plays no role in my explanation. If I consider an experiment of which I described before, like this one, I send a particle and I have my photomultiplier, my macroscopic detectors. Macroscopically different states of macroscopic objects are created. Here also there is some current. It also goes to observer. But even here, my photomultiplier has many, many, many atoms. So at this stage, we have very different states of two photomultipliers. There is no any chance to see interference between them. This is the possible to coherence. I say it doesn't work by itself. Let's say we have just the same experiment, no macroscopic detectors. I send a single particle, and this particle changes polarization of my molecules or whatever when it's going on the way. So this is really kind of a path of my particle, and every time it goes through, it, let's say, flips the spin. So they will be flipped here, will be flipped here, given the particle is here, or flipped here, given the particle is here. Now, when I look on this picture, I don't see any macroscopically different state of any macroscopic object. There is no any new word. There is no word A and word B. Of course, this branch and this branch, if we want to call them this way, completely decohered. Many, many molecules flipped, and so we cannot, will not be able to make it to see interference later. But macroscopic objects didn't change their state. So from my point of view, there is no different story. There is no different word. Moreover, if all these particles would be parts of EPR pair, then locally will be no change whatsoever. The coherence will happen because my entangled particle will have different states, but locally, no change whatsoever. The word does not split. Okay, so let's go then to this probability issue. First, I think the first problem is to understand the meaning. Because what I understand in probability is when A or B might happen, I can talk about probability of A or of B. But if both A and B happen, there is no meaning to talk about probability. So, since I know that in this quantum experiment, both A and B will happen, I say there is no meaning. I cannot talk about the meaning of probability. I cannot, the question, what is the probability that the observer will be in the word A, will get an outcome A, has no meaning. He will have two descendants, one of which will be in A, definitely. We have one in A, one in B. There are two of them, one of them in A. No meaning. I cannot ask this question. There is no meaning for this question. Now, if there is a meaning after I made an experiment, in normal experiment, there will not be interesting meaning because, okay, experiment has been done. The B knows that it's B. The probability that he is in word B is just 1. So there is also nothing interesting after the experiment. But let's consider some variants. Maybe I'll put some impenetrable wall, and I'm here. I know that the experiment will be performed. Somebody will run automatically, or my students will run the experiment. And I know that the word split. There is outcome A, and also there is in parallel world outcome B. But I have no idea what it is. Nothing penetrates. So my wave function didn't change. I claim that in this case, for isolated observers, there is no any meaning for probability either. It's the same like the experiment in the future. Because I will be in both worlds. if nothing changed with me, there is particular wave function of me. This is me, and I'm in word A and I'm in word B. So if I still want to kind of understand and create a situation in which I can talk about probability in many words. This was, in fact, in this my paper, I call it sleeping pill experiment, but here I will do it in a different way. There is a wall, I don't see what's happening, but there is a student who sees the outcome and then comes to me to tell me. So the experiment is performed. And then the student comes to me. Before he tells me what is the outcome, there is a perfect meaning for me. What is the probability that I'm in word A? Because A and B clicks, the student will come to me slightly in different way. He will look slightly different, maybe slightly in different time. There will be some difference. So when I see him, I will be different too. My wave function will change. Until he'll tell me what is the outcome, I still don't know what is the result. But I am in one of the words. There is a matter of fact for me here, in which word am I? In this case, after the experiment, there is no matter of fact in which word am I. I am in both words. But here, after this experiment, for each one of me, there is a matter of fact. So there is a meaning, and I don't know. I have an ignorance probability of the outcome of this experiment, and I can put my quantum probability is Born rule or any other rule I want to accept. So the question has meaning for both observers. Each one will see this, will see student here, another will student be here. And in fact, in both cases, he has the same information. So in both cases, if he wants to put some information, some guess what is the probability, he should put the same. If he believes in Born rule, so he should, both Lev A and Lev B should say the probability of me being in A is just alpha square. So I summarize. Before the experiment, and this is somewhat strange. I'm going to perform an experiment, and the experimentalist asked me, can you tell me about the probability? I say, no way, there is no meaning for this question. He performed the experiment, but I'm not influenced. What is the probability for the outcome? I say, there is no meaning. Only in this special case, when I'm affected by the result of an experiment, but not in the way that I know the outcome. Only here I know the outcome. These subtle differences, in fact, I think conceptually important when I cannot talk about the concept of probability. But for my behavior, they are not important. In all cases, I should behave as if there is a meaning of self-locating probability. Because what is the meaning of probability? What I know from the Finetti, intelligent bet. This is the meaning for probability. Bet is for my descendants. My descendants might be in a position that they will be influenced. For them, there will be meaning. Since I make a bet for them, so I can accept their concept of probability. But maybe I can do another thing. I just accept behavior principle. I care about my successive words according to their measure of existence. Look on this measure of existence. First, I have this postulate about self-location probability when it is applicable. I should, my probability is according to this measure of existence. Second, I also say there is a behavior principle. One are really strongly related to the other one, but also I can say that I accept this other one because in some sense, sometimes I exist more and sometimes I exist less. What might be a meaning for this? The meaning for this that if one word exists more, it has more power of interference with other words. So word is a wave. Everything is wave. Interference of words, interference of waves. So I can say, let's say this is a wave of one word, and this is wave on another word. And let's say this is a quantum state, we have this superposition of two words. And if we have some Wigner with super technology, we can play and interfere words. So let's say, for example, that our measure of existence are equal. Measure of A equal measure of B. Then it seems that these words can have constructive or destructive interference. We can maybe rotate this, and then we can move it. You see, 1 plus, 1 minus, so maybe we'll get something like this. This is too naive and wrong. We cannot do this kind of interference. This also not true for normal waves on a string. If I send this 2 waves on a string, when they're here in the middle, I look on the string, it looks like this. Can I say that my waves disappear? This will be a mistake. Waves is really motion of this particle of string, and they have particular velocity. And this is velocity in the front, it's go up, so it can, and here it's go down. There is no really motion to the left or right. The only motion is up and down. So when these 2 waves come together, we have this is up and this is down, and here we also have this is up and this is down. So although we see no string, but there is a velocity. Now in quantum physics, there is no phase space. So it's we will not see kind of no wave function here. In fact, there will be a wave function here too. We cannot really get destructive interference in this way. So how we can see this ability to interfere? To see the ability to interfere, it's necessary to make more splitting of words. If word doesn't split, there are many words, they can live one with other and they will see no interference whatsoever. Only when one word splits, it can that we can see interference with other words. So let's see on this word, and let's put some barrier, and it's sometimes goes through and sometimes reflected, and let's say after reflection we'll get, after this experiment we'll get 2 words. In fact, it's possible. I can do it for photon, and then deciding of what photon will tell me, I will move. Now, when I have now from A, I will get these 2 words, D and C in a superposition. There is another word which will bring me to the same words, D and C, if I'll send it from the right. If I'll send from the right, and I will get this picture. And of course, it must be orthogonal, this orthogonal to this one, and this orthogonal to this one. So the standard in optics, it goes through without phase, reflected with I, then I can write something of this kind. Automatically, I get the right kinematics of my waves. So if I have 2 words, word A and word B, this has alpha, this has beta. After this experiment, I will have interference. What will be here? It's I alpha plus beta. So I can, if I start with A, I know I should be both here and here. I know I have a chance to be here. If my word beta is of the size of alpha, I can avoid this. I can make that beta equal minus I alpha. And then this word will not happen. Only this will happen. And vice versa. Now, if I have more than 2 words, A, E, and F, with different amplitudes, then how I will interfere them? This a simple way to understand, well, is just to take 2 words and make 1 out of them. I can take, let's say this is words, a measure of existence. I take two words. I can engineer a particular barrier that after this experiment, I will get one word. They go together and they interfere destructively here. Even the alpha E and alpha F are different. I have to play with my barrier. Now this one I can put here to interfere with A. And my kinematics will tell me that the measure of existence of my joint word is equal to the sum of measure of existence of each one of them. So if I use my slogan or my postulate, probability is proportional of self-location, proportional to the measure of existence of a word, it gives me the Born rule automatically. Okay. Now, a derivation of the Born rule. Wojciech has derivation, many others have derivation, I also have derivation. But I think my main claim is that all of them need some assumption. I think it's important to understand that if we do not assume maybe something very natural, we cannot derive a Born rule. I had that there are these two principles of connection between the ontology. The ontology is simple, it's just a wave function. The interpretation is this connection between the ontology and experience, and it has two parts. First, how, if there is a particular wave, what I experience, and then if there is a special situation in which I know that there are several words and I don't know which word am I, the self-location. This is additional postulate. I claim it cannot be derived from formalism of the quantum mechanics. And my proof is just a simple exercise. I suggest an alternative, which is different from the Born rule, and it does not contradict unitary quantum mechanics. It's kind of very stupid and very wrong, although some people who wanted to attack many words frequently use it. All words have the same probability. If we have zero amplitude, it's not a word. Every word with non-zero amplitude has zero probability. It has the same probability to be of self-location. It's very bad idea. It's I can send signals faster than light. I can. There are many reasons why not to believe in it, but it's consistent with unitary evolution of the wave function. I can believe in ontology of the wave function, and then about this self-location property, the property, what is my probability of self-location? I can, in principle, accept this. It will contradict my experience, but it will not contradict the ontology of the wave function. So let's go to experiment. I have a word splitter, and I will perform the experiment demonstrating these probability issues which I said. I had this no meaning of self-location when I before the measurement. Isolated observer. I have this observer which was affected by a student which said that the experiment happened. And I also have this experiment equal probability rule or other probability rule. So how I'll do this? I have, in fact, in my splitter equal probabilities. Just I will, before the experiment, here there is nothing special, just performing the experiment. More tricky is this one. I want to perform the experiment, but want to be isolated observer. I will name the words A. And in this way, I will really not know what will be the outcome. And in fact, you also will not know, because you will see exactly the same what I will see. Now, to make an affected observer, what I will see, I will switch off my monitor and I will not see the result. But all of you will see, and I will ask Charles to tell me that he has seen. I believe that this, in different words, it will be slightly different. So in this moment, I will be in a position now of proper uncertainty. There will be matter of fact for me what is the outcome, but I will not know it. And similarly, I will try to make, I will test this probability rules. Born rule, according to measure of existence, or all words are equal. This I will ask your help. I will ask you to perform splitting in case of A. Again, I will close my monitor. I will not see what's going on, but I will ask you in A to make splitting. So will be many words A and only one word B, and then probability of B should be very small for me. Okay. So this is my word splitter, and you are welcome to play with it. This is how you get to it. Now I will get to it. This is my word splitter, and so I want to split it in two. I write here A, I write here B, and split will make will be connection to some quantum device, which finally will give me the outcome. I really believe that also here I and you together with me will see A or B. I really know that there will be all of them. So I cannot say what is the probability that I will see A or B, because I will see both of them. So let's split. I'm in B, but I'm absolutely sure that there is also A. Anyway, let's go to the next experiment, a little more interesting. If I write here A and write here A, this device is stupid enough, it will not tell me that it's the same, so it's not ready to run. It will make the split. And the split is a kind of a time of arrival of a single photon detector. So something macroscopic will happen in the device. But the interface in the end will give me just one reading. So now make a split. Until now, the word didn't split yet. I made a split. The word split. I don't know, it's maybe word A1, A2. One of them in my device happened. But it gave me, and the device is far away, so there is no connection to me. I didn't change, my wave function didn't change. All what I see is A. So I'm isolated observer. I don't know what really happened. So I say, in this case, although there are two words, word A1 and A2, there is no meaning for probability for me being in A1 or A2. I'm in both of them. Maybe there is some leakage and something changed, I'm not sure, but as far as I understand physics, this is the situation. So let's go to this next one. When I will ask Charles, after some time, again, I put A and B, and now I put my cursor on split, and I will switch off my screen. So the end, I can split. I believe now that splitting happened, and I'm in a position that I don't know, that I cannot really, I have no meaning for probability, because I didn't change. But Charles, please tell me that you have seen the outcome.
I have seen the outcome.
Now things are changed. Now there is a legitimate meaning for probability. I'm pretty sure that I'm in a world with particular outcome. I will try to put my screen again. Sometimes it takes some time for it. And I will see the outcome which all of you have seen. Okay, it's come back. So we can make this final experiment. My first will be A, and I will write split. And also I will write you this web, so all of you can easily put it here. You will see if it's split, you will see this. If it's B, you will not see it. And I ask you, please, after you'll see the outcome, or A split or B, if you'll see split, please go to this and make a split. And make me, if you go to 6, for example, you'll split to 6 words. But you have to mention something for every one of them. You have to write something, otherwise it will tell you that it doesn't work. So let's do this. I close my monitor and I make the split. And let me wait for a while that some of you will have some time to do the experiment. So again, I'm now an isolated observer. I don't know what happened, but this is not what I want really to test here. Although I have many other reasons to believe in Born rule, but this is another experiment on the Born rule. So I hope at least until the time the screen will come back, usually will take time. Doesn't. I have more time. Sometimes it's, yeah, okay. Oh, I'm sorry, because what's happened, my cursor stopped on 6, and so it was a new one, so experiment hasn't been performed. I do want to perform the experiment. I'm sorry. So again, so it's A, and this is, you understand what happened, because when I closed my things in real world do not cooperate. Okay, A and B, and now I put it on split. I close my, now I close it, and I okay. Now I hope some of you had the chance to, will have a chance. If it's A, if it's B, you're not supposed to do anything. So okay, so it's B, and the point is that the fact is B is kind of a proof, not decisive, that the Born rule is correct. Because I definitely know that there is a parallel world with A. In A, I hope many of you, there are many people, so there are many of them made the splitting. So it's all multiplied. So there were many, many, many words A. So if the probability rule is one of the number of the words, to get B is very, very improbable. So it's kind of an experimental proof that the Born rule is true, and this strange rule that all words are equal, which in some way may be Simon trying to defend, but maybe he has different words, is not true. So I think I can come back to my last slide, and here I will stop. Let me come back again to this slide. And okay, so instead of conclusion, I have a summary of all claims, which, as far as I know, at least some people find controversial. And I believe that the resolution of controversies is really what helps. So single word quantum theory invariably leads to action at a distance. We have macroscopic objects that describe a product quantum states in 3 dimensions. The coherence due to environment plays no role in many word interpretation. There is no meaning for probability for outcome of future measurement. After the measurement, there is meaning, but only for an observer who was affected by the outcome. Objects, words, exist in physical universe with measures which are not just 0 and 1. Bond rule cannot be derived from quantum formalism without some additional assumptions. And the many word is by far the best interpretation of quantum mechanics. Thank you.
Thank you, Lev. Thank you very much for the nice talk. We have a few minutes for a question. If anyone has a question, there was a lot of stuff in the chat, but suppose the easiest way is to raise your hand. Then I will call your name and you can simply unmute yourself. So the first hand raise that I have is by Jaka. I hope I pronounced your name right. Jaka, would you like to ask your question?
Yeah, can you hear me?
Yes,
yes.
I do.
Okay. Thanks for the talk. It was nice. I'm just, when I think about many worlds, there's this, it's a slightly vague concern, but I hope I can make it somewhat precise. It's basically, I'm sitting here and then in the future tomorrow, there will be several copies of me in different worlds. How do I know which one I become, in a sense, or why do I have today the memories that I have? That is something that some kind of confuses me.
So first, there is no meaning which one you will become. You will become all. This is one of the things. No meaning what will be the outcome of what is the probability for an outcome, because all outcome will happen. You cannot ask the question, who will you be? You can ask the question, who you was, because when you go backward in time, there is a well-defined world. The structure, when you're in a tree, you can go backward and it's exactly defined. If you go forward, it's splitting. You don't understand. I don't want to accept, by definition, I is some local creature in one place. I don't to be I in several places. I don't call it I. So I cannot say, who will I be? Because I will be in all of them. But there is a well-defined meaning who I was.
All right. There's another question by David Wallace. David, would you?
Thank you. So there are fairly well-known concerns about consistency for the extra probable example that you give, which I think you're aware. Excuse me, baby. Which I think you're aware of. One being something like, okay, so I do an equally weighted split into two. I do a split into two branches, A and B, and then branch A splits into A1 and B, and A2. So if you fine grain that situation, you end up saying, okay, I've got probabilities 1/4, 1/4 according to the splitting rule. If you coarse grain and step out, you've got probabilities 1/3, 1/3, 1/3, because you've just got 3 branches. So when you talk about the branching being that probability rule being consistent, what is the notion of consistency you have in mind?
So there is a vague concept of when the branch is a branch. But let's say, and some GRW people like this idea that there is a minimal amplitude when it exists, and below this it doesn't. So if we'll accept something of the kind, then I can say when the world exists and when the world doesn't. And then everything is okay. Of course, there is a very strange thing. There is a half and half before, and then I split another one. And this is a half before, now it's 1/3. This is the rule. It's non-local rule. You can send signals faster than light. It's non-locality, whatever. But if I'm super intelligent, I have this wave function and I'm external and I look on the wave function, my wave function will not change its behavior. So there is complete consistency with unitary evolution of the wave function and with this story. Because this story, it's kind of a new story. There is a situation. I know now I performed this experiment when I was in a position which I didn't know in which world am I, and the word really legitimate meaning in which we are. And then I put my probability. It might be one, it's logical to say that in this kind of cases, the rule is just defined by number of words. Very unphysical, very whatever, but consistent.
So there's something I'm concerned about. I mean, I think the notion of consistency here is very narrow. And there are diachronic multi-time aspects of probability as well. And I'm concerned that you haven't got consistency for probabilistic updating.
Yeah, of course, there is no diachronic. If there is a probability in what I showed for Born rule, which was measure of existence, of course, if I had the word E and G and it go to F, F has the same measure. F go to E, G, the sum of measure remain. Here, of course, now the probability, if I split the word, the probability of other words change. There is now, this property is not there.
Now I think you have an inconsistency. If you try to plug that into the normal calculus we use probability in, you're going to find this. I mean, if you know, various different ways setting up validate finetti, you're going to run into contradictions.
I'm not, again, let's say this word B. I could immediately open it in B, and then I found B, and okay, the fact that many people will split other ones, this will not change it. But if I will not, then I will be new, and I will be surprised. What is probability? It's how much I surprised. And then so this is in all this repetition, how much I will surprised. There is no any, of course, if you want this diachronic consistency, other things, it will contradict it. It doesn't has this property, but well, it does not break in any way whatsoever unitary evolution of the wave function.
And I don't want to hold people up, but maybe the take home I want to suggest is that when you say this rule is consistent, there's a lot of content going on in what's actually required for a probability rule to be consistent. And I think under a lot of interpretations of probability, it's not a consistent rule.
Consistent does not contradict unitary evolution of the wave function. Contradicts many very natural other properties.
But I'm not sure what it means to say that probability contradicts unitary evolution. I mean, I'm not even sure what the words in that sentence mean. I mean, I can understand what it is for a notion of probability to be consistent, to obey the calculus of probabilities and things. But I'm not sure what you mean when you say it's consistent with unitary evolution.
It's not dependent on unitary evolution. Unitary evolution, it's independent. The people inside will be able to send signals faster than light. Super technology manipulating the universal wave function will not be able to use these people to send signals and light. So they will have a covariant quantum mechanics.
Okay, I'm not going to follow up. I want to hold people up here. I don't think this is productive.
Okay, I see some more hands raised. Wojciech, would you like to share your question?
Yes, it's sort of half comment, half question. So early on in your presentation, you said a macroscopic object, whatever that means. It's a fairly incomplete definition. And, you know, a lot depends on that. You endow macroscopic objects with properties which are not quantum, right? And my feeling is that when you say at the other moment of your talk, that the coherence doesn't matter, is that's what you are missing in the definition of macroscopic objects.
There is one postulate of many words, unitary evolution. It's exact and physical. Second, two postulates of connection to our experience. These postulates are not exact. They, for us, all this concept of macroscopic object, it's to help us to make connection to the exact ontology. So the macroscopic, you can play with it, fine grain, less fine grain. It's not, I don't claim that there is any process. There is no collapse happening where I have to say what is macroscopic exactly. It's just to explain my story. And it's like a Heisenberg cut, which is can be very flexible. Macroscopic is very flexible. So there is no difficulty here. It's vague, but because it's about social science, it's about helping me to make connection of my experience, which is social science, to exact science, which is in ontology of the universal wave.
So I have a feeling you're avoiding defining it. I mean, whenever you have a flexible definition, it often ends up being an imprecise definition. And, you know, so far what you've said, I think doesn't contradict what I've said. And I really think that macroscopic localization, product states, etc., follow from the coherence. You don't want to accept it, it's fine with me. I'm not gonna twist your hand, but I think this is true. And that's fine.
May I just, it does not follow, it goes together. I don't need it. In all my macroscopic objects in real life, they all decohere. It's I have to bring very super technology to avoid this decoherence. So I can use the coherence maybe to help me to, but I don't need it. I prefer the story. My different words are different stories. So definitely I have situations in which there is decoherence and there are no different stories. So I don't want to say that I have different words. So this is why I don't want to go from decoherence. But in all my words, in all real life, there is a decoherence. It goes together, and maybe I'll use your machinery to help me to find some properties. It's not, but I can do without it.
I don't want to prolong this. I don't think you appreciate what it can do for you, but that's all right. I'm done.
Okay. Simon, I think you're in line.
Yes. Hi, Lev.
If Zoom works properly, then I think it's put in order.
Yes. So, Lev, I think I understand your point of view, I think, and it's essentially an operationalist one. And as such, I suspect it's defensible in all of the ways you've been defending it over the years. And in a way, I don't have to have a quarrel with it. But I think insofar as you're giving a view on the uses or values of decoherence theory, it's just uninformed. And the sort of thing I've got in mind is if you're going to look at sort of mesoscopic phenomena at all, and one wants to be a realist about it, you'd better care about decoherence theory, and you'd better study models in non-equilibrium statistical mechanics or just derivations of various equations for reduced density matrices, and so on and so forth. And if you do look at all of that and what is going on there, then you will see, and learning from one of the giants on whose shoulders we are standing, namely Wojciech's, that decoherence theory is actually informative as to what are the relevant states. And what's more, it provides exactly the same informative account of why macroscopic objects are well localized in position, momentum, and so forth. So, you know, that's something that you can just shrug your shoulders as you're doing and say, I don't need it. You're just taking it as just a given. But many of us are seeking a deeper explanation for quasi-classicality, and we find it in decoherence theory.
So the coherence is important. You know, I performed many optical experiments, and it's very important for me to see coherence. Otherwise, it's lost. I want to explain Anderson localization. People say it's very important. I want to explain many other things. I don't think that physicists do not have to study the coherence. To explain my experience, I don't need it. To explain my experience, I have this of course, to explain superconductivity, superfluidity, and when it breaks down, I will study exact things and I will talk about the coherence. But to explain what I see in my room, objects, what is cat, what is whatever, what is stable, I don't need it. Because stable cannot interfere even if super technology will avoid the coherence with air. Therefore, I don't need it.
Well, just to repeat, indeed, so long as you are concerned only with your operational interpretation of quantum mechanics, you don't need decoherence. You can be dogmatic about the various features of experience that we find, and that's what you are. But others of us are interested in giving an explanation, as I say, of quasi-classicality and how it arises.
We are local not because of physics. We have to say evolution, maybe some Darwinism in a sense. We cannot be non-local creatures. Maybe this the coherence will tell us, because if I'm in a superposition of here in another places, if I want to eat lunch, I need 2 lunches. So something apart from the coherence, this is impossible to have these non-local creatures which exist in 2 places. And so I need objects and interact. All interaction is local. In the end of the day, the key. Some people start with Hilbert space and then nothing is clear. There is a locality of interaction, so we live in 3D. Because interactions happened in 3D, and you can see this interaction between a macroscopic object. I'm a macroscopic object, and my glass with water is a macroscopic object. And I don't need that that how fast air knows about the presence of my glass here. There will be no interference of my glass anyway. To make interference, I have to make splitting and very careful splitting, keeping coherence. This is out of question, so it's not relevant.
Did I detect the attempt to explain why we are a localized object on the basis of an anthropic argument? Something like that? It would be interested if that were to be developed at all. Anyway, I think I've made an observation for a lot of people, and I'm not really expecting to get you to agree with me, but thank you, Lev.
But again, this is further question. The title of my talk, many words explain in the best way the results of experiment. And so this is what I say it does. I agree that to make evolution, cosmology, other things, these are the next question, which I don't touch definitely in this talk.